This problem tells us that we need to find the exact value of the sine of alpha minus beta, but we don't know what the angles alpha and beta are. We do, however, know that the cosine of alpha is square root of 3 over 4, and the cosine of beta is negative square root of 2 over 3. We also know that alpha is in quadrant 1, and we know that beta is in quadrant 2. So we need to find the sine of alpha minus beta. So to do that, we are going to use this identity right here. The sine of alpha minus beta equals the sine of alpha cosine beta minus the cosine alpha sine beta. So for this one, we need the sine of both alpha and beta and the cosine of both alpha and beta to use this identity. Well, what we've been given is the cosine of alpha and the cosine of beta. We don't know the sine of either. So we need to find those. We need to find the sine of alpha and the sine of beta. Okay, we know the cosine of each, but now we need to find the sine, so we can use our identity for the sine of alpha minus beta. To do that, now to find the sine of alpha and beta, we're going to use this other identity, the sine squared of x plus cosine squared of x equals 1. Now we can solve this for sine squared of x. So we get sine squared of x equals 1 minus cosine squared of x. And that's the identity we're going to use to find the sine of alpha and beta. So the sine squared of alpha equals 1 minus the cosine squared of alpha. Well, the cosine of alpha is square root of 3 over 2. So square root of 3 squared is 3. And, it's over 4, sorry, and 4 squared is 16. So we have 3 over 16 for the cosine squared. Square root of 3 squared is 3, and 4 squared is 16. So we can find a common denominator, so we can combine this. So we have 16 over 16 minus 3 over 16, which is 13 over 16. So that's our sine squared of alpha is 13 over 16. We need to take the square root of both sides, though, because what we want to know is the sine of alpha. So the sine of alpha is plus or minus the square root of 13 over 16, which is plus or minus square root of 13 over 4, because the square root of 16 is 4. Okay, well, we have two answers. Which one do we want? Do we want the positive answer or the negative answer? That depends on what quadrant alpha is in. So alpha is in quadrant 1, it already tells us. And the sine of any angle in quadrant 1 is positive. So we do want the positive answer. So the sine of alpha is square root of 13 over 4. Okay, so now we know the cosine of both alpha and beta, and we know the sine of alpha. We need to find the sine of beta next. So let's find the sine of beta. We're going to use the same identity, the sine squared of x equals 1 minus cosine squared of x. So we know that the sine squared of beta equals 1 minus the cosine squared of beta. The cosine of beta is negative square root of 2 over 3. So we have that equals 1 minus negative square root of 2 over 3 squared. So we have 1 minus negative squared makes a positive, and then square root of 2 squared is 2, and 3 squared is 9. So we have 1 minus 2 ninths. Find a common denominator. We have 9 ninths minus 2 ninths, which gives us 7 ninths. Okay, so that's what our sine squared of beta is. Take the square root of both sides, though, because we want the sine of beta. So plus or minus square root of 7 ninths, which is plus or minus square root of 7 over 3, because the square root of 9 is 3. So again, we have to decide, do we want the positive or negative answer? Well, beta is in quadrant 2, and in quadrant 2, the sign is positive, so again, we want the positive answer. So our sine of beta is positive square root of 7 over 3. Okay, now we know cosine of alpha, cosine of beta, sine of alpha, and sine of beta, so we can use our identity for the sine of alpha minus beta. Okay, so let's do that. Here we have the identity sine of alpha minus beta equals sine of alpha cosine beta minus cosine alpha sine beta. And we have the cosine of alpha is square root of 3 over 4, cosine beta is negative square root of 2 over 3. Sine of alpha is square root of 13 over 4, and sine of beta is square root of 7 over 3. So we're just going to plug all of these into our identity. So sine of alpha, so we want to know is sine of alpha minus beta, which will equal a sine of alpha, square root of 13 over 4, times the cosine of beta, which is negative square root of 2 over 3, minus cosine alpha, so square root of 3 over 4, times the sine of beta, square root of 7 over 3. Okay, I just plugged in the sine of alpha, cosine alpha, and sine beta into my identity for sine of alpha minus beta. Now I'm just going to simplify. So I have a negative times a positive for this first term, so it's going to be negative. Square root of 13 times square root of 2 is square root of 26. 13 times 2 is 26. In the denominator, we have 4 times 3, which is 12, minus square root of 3 times square root of 7 is square root of 21, and 4 times 3 is 12. We have a common denominator already, so we can just combine these. So we have negative square root of 26 minus square root of 21 over 12. And we're done. That's our answer. Negative square root of 26 minus square root of 21 all over 12 equals the sine of alpha minus beta.